The fourth question that we have is a very interesting question. We have been given there are two speakers placed 1 meters apart. They vibrate in the same phase and have a common frequency of 1800 Hz. A detector which is moving on a line parallel to this at a distance for 2.4 meters apart detects first maxima at this point, and then it keeps moving down and detects another maxima at point P. Using this information, we need to find out the velocity of sound. So, when we had the first maxima here, there must have been constructive interference. Now, since both of them are vibrating in the same phase, therefore the phase difference over here would have been either 0, 2 pi, that is even multiples of pi. Now, that is equal to k times delta x is equal to even multiple of pi. Now, at this point, we can see clearly that this is 0.5 meters apart. Therefore, this distance will be equal to this distance, since this point is located on the central line. Therefore, the path difference at point O is 0. Therefore, the phase difference which is developed at this point must be 0. Now, therefore, the path difference is 0 and the phase difference is 0. Now, as we keep moving down, the next first maxima occurs at a point where the path difference will be equal to lambda. Now, it is crucial to understand that the path difference at this point is 0. So, as we keep moving down, the path difference will keep on increasing. So, there will come a point where the path difference becomes lambda, and at that point we will have a maxima again and a constructive interference. So, it is given that the next maxima occurs at point P. So, therefore, P is the point where we have a path difference of lambda. So, at point P the path difference is clearly equal to, let me draw the diagram again here. We have S1 and S2. S2 is located at this point. We have S1 over here, and this is the point P. The distance of P from S2 clearly is 2.4 meters. This is given to be equal to 1 meters. Therefore, we need to find out the distance of P from S1. Let this be theta. Therefore, we clearly see that we do not need theta over here. This is equal to 2.4 whole square plus 1. Therefore, the path difference at point P is equal to root over 2.4 whole square plus 1 minus 2.4. Now, we know that this path difference is equal to lambda. Now, the frequency of the source is given to be equal to 1800 Hz. Now, we know that lambda f is equal to v. Therefore, the velocity of sound will be equal to 1800 into root over 2.4 whole square plus 1 minus 2.4. This is equal to 5.76 plus 1, that is 6.76. Root over 6.76 is 2.6. 2.6 minus 2.4 is 0.2, that is 1800 into 0.2 meters per second, that is equal to 360 meters per second. So, final answer for the velocity of sound using the given information comes out to be equal to 360 meters per second. The important thing you should have learned from this question was that when the path difference over here at this point is 0, as we keep moving down, the next maximum will come at point where the path difference is lambda. So, we get our final answer as 360 meters per second.